morning, good evening, good afternoon, depending wherever you are seeing me on the globe. Today we are going to continue with a series of titration practicals. But today we are just going to go through some of the questions that usually are tested in the practical classes. So now today we are just going to discuss those questions in relation to in as far as the nitric acid and sodium carbonate is concerned. So there is a procedure on the board that I've already written to save time for this discussion. So I will just take you through the procedure as we continue with the other calculations. So titration practical 2, you are provided with 0.2 molar dilute nitric acid and sodium carbonate solution. You are required to determine the concentration of sodium carbonate in grams per liter. Procedure: fill the burette with dilute nitric acid. 2. Using a pipette, fill a pipette 25 cubic centimeters of sodium carbonate into a clean conical flask. Then add 2 to 3 drops of methyl orange indicator. Titrate sodium carbonate against dilute nitric acid in the burette and record the results in the table below. So now this is the table. Let us now assume we have filled the burette up to the 0 mark. So we have titrated, then it has changed on the 15th mark. So we are going to record here on the final burette reading 15 here. And then the initial we record 0.0. So on the second titration, we are starting at the 15 mark. So now we have titrated, it has changed up to the 30 mark on the burette. So now we are just going to take that 30 as our initial volume. We titrate and then it changed our third reading on 45. So now we are going to subtract from the final from the initial. So we have 15, we subtract from 0, we get 15.0. Then from there we get 30, we subtract from 15, we get 15.0. Then 45, we subtract from 30, we have found it is 15.0. So now the question is asking, the first question, we are supposed to determine the average volume of the acid that was used. So the average volume of the acid that was used is equal to first theta plus second theta plus third theta volume. Then we divide everything by 3 because there are 3 titrations in cubic centimeters. So we are going to write 15.0 plus 15.0 plus 15.0. Then we divide by 3. All these are supposed to be cubic centimeters. So it's going to give us in cubic centimeters. When you do your calculations properly, it's giving us 45.0 divided by 3 in cubic centimeters, which is equivalent to 15.0 cubic centimeters. This is our average volume of the acid that was used. So now the second question, we were supposed to determine the number of moles of nitric acid in a solution. So we have answered question number 1. Now we are going to question number 2. Determine the average. Determine the number of moles of nitric acid solution. Determine the number of moles. The number of moles of nitric acid in the solution. So we are going to calculate it. We are going to approach it. There is a way whereby we can approach it either using one procedure or the other procedure. But in this case, we are going to determine the number of moles is equals to molarity times the volume in liters. Number of moles is equals to molarity times volume in liters. So number of moles. So we are just going to do a substitute. This molarity, remember we have been given here 0.2. So we are going to say 0.2 times the volume in liters. Remember, in this case, the volume in liters will be given 15 over 1,000 cubic centimeters. Remember, we are using this average volume over 1,000. So it's when you do your mathematics properly, this one is just going to give you 0.003 moles. So we have answered question 2. So we are going to question 3, whereby it's going to, we have been told to determine the number of moles of sodium carbonate solution. So we are going to write here, determine the number of moles, the number of moles of sodium carbonate solution. Remember, before such kind of a question, you cannot answer it before you write the chemical, the reactants and the products, because this is a reaction. And therefore, we are going to write starting with nitric acid plus sodium carbonate. It's going to give us sodium nitride. So this is how the sodium nitride is written. Nitride, it's written like this, plus carbon dioxide plus water. So after we have written this, we are supposed to ask we are supposed to ask ourselves, is the equation balanced? And also, have we written the complete states of each reactant? Because this is the reactant side and this is the product side. So this is a liquid, this is gas, this is aqueous, and this is aqueous. After we have done that, we need to ask ourselves, is this equation really balanced? The answer is no. So if our answer is no, we are going to consider some of the atoms within these reactants, within these compounds, because this is the reactant side and the product side. Now, so we are going to write our 2 here so that we see whether our equation is going to balance properly. So we have 2 hydrogens. We also have the 2 hydrogens. So those hydrogens are balanced. So these two nitrogens, and then these are 2, like our nitrogen here is 1. So we are going to add some 2 here, so that we have two nitrogens here. Then oxygens. How many oxygens do we have? Here we have 6 oxygens, and then here 9 oxygens. Here we have 6 oxygens, 8, 9. So oxygens are balanced. Now we go to nitrogen. Oxygens are balanced. Now we go to the second reactant product. Now sodium carbonate. Sodium, we have 2 sodiums there. Carbon, we have carbon 1. Oxygens, we have seen that we have how many oxygens? The oxygens are also balanced. So our equation is balanced. So in this case, our mole ratio is 2:1. So after you have written this, you are supposed to ask yourself some questions. The question it was asking to determine the number of moles of sodium carbonate in that solution. The number of moles of sodium carbonate in that solution. Remember that the number of moles in this, it goes, we have already found that the number of moles, we have determined the number of moles of nitric acid in that solution. So we got this. So if we are supposed to calculate the number of moles of sodium carbonate in this solution, it's going to be a half times 0.003 moles. So because of the mole ratio, but if it could have been 1:1, then the number of moles would have remained 0.3. Since we are calculating the number of moles of sodium carbonate, this is 1 and this is 2. Because of the mole ratio, we are supposed to divide by a half. So we do our calculation like this. Then, so the number of moles of sodium carbonate is equals to 0.0015 moles. So we have answered that question. We are going to determine the molarity of sodium carbonate. We have been told to determine the molarity of sodium carbonate. So this is number 4. Determine the molarity. Remember, molarity is written by capital M, molarity of sodium carbonate. So we are going to ask ourselves, because we were pipeting using 25 cubic centimeters of the pipette, and always, if you have been told to determine the molarity of sodium carbonate, always molarity is equal to number of moles. Molarity equals to number of moles divided by the volume in liters. So it's going to give us, if we substitute it properly, 0.0015 times. It's supposed, if you do your calculation properly, you will find that it is giving us, this is 1,000 cubic centimeters, and then we divide by 25, which gives us 0.006 N. Next, we have been told to determine the concentration of sodium carbonate. We have been told to determine the concentration, number 5. Determine the concentration of sodium carbonate. If you have been told to determine the concentration of sodium carbonate in grams per liter, we are going to approach it this way. Concentration always is equivalent to, concentration is always equivalent to molarity times the RFM. Molarity times the RFM, which is going to, if we substitute it properly, we are going to substitute it with 0.06 times 0.006 N. 0.0, it's supposed to be 0.06. Sorry, it's supposed to be 0.06 N times RFM. If we do calculation of this sodium carbonate, we are going to calculate the RFM of sodium carbonate. Remember, sodium, relative atomic mass of 1 sodium is equals to 23. Relative atomic mass of carbon is equals to 12. Relative atomic mass of oxygen is equals to 16. So in this case, the whole of this atom, it is sodium. Sodium, there are 2. So this is going to be 2 times 23 of this will give us 46. Then we go to carbon. Carbon in this case is just 1. So we are going to have 1 times 12 to give us what? 12. Then oxygens. How many oxygens do you have? 3. So it's going to give us 3 times 16. If we do our mathematics properly, 16 times 3, it is giving us 16 times 3, this is 18, and we need 21, 24, we write 4, then we carry 2. So it's going to give us 16 times 3, it's going to give us 48. 48. So it's going to give us 48. Because here it's 8 carry 1, then it's going to give us 48. So 106 grams. This is the relative formula mass of sodium carbonate. That's why we are going to write here 106. So it's going to give us. Now, if you do your mathematics properly, you are going to get 6.36 grams per liter. I hope we have come to the end of our virtual practical class. Please remember to subscribe, to comment, to like and share. For those few remarks, meet you next time in the next virtual practical class. Bye bye.